So, hi children. So up to now we discussed about that types of numbers, right? So in that types of numbers also we discussed up to fractional parts. So once again I am recalling that in the types of numbers, what is the first type of number here? That is natural numbers. Next whole numbers. Next we discussed about that integers. Integers after we discussed about that fractional part. Okay, fractions. In that fractions again how to represent that fractional parts, that one also we discussed, right, in that previous video. Okay, if anyone missed, just go for that video and once observe that. After completion of that video, come to this video and continue this one. Okay, so in this video today I am going to discuss about that the leftover types of numbers. Okay, still we have that some other types of numbers, no? So what are those numbers? So the leftover one: rational numbers, irrational numbers, real numbers, imaginary and complex. So we will discuss this all about in this video. Okay, let us see about that rational numbers. So what about that irrational numbers? A number which can be expressed, in P by Q form. What is that? A number which can be expressed in P by Q form, where P comma Q belongs to integers, belongs to Z. P comma Q belongs to Z, which means integers, and Q not equal to 0. Q not equal to 0 is called a rational number. Okay, this is that condition. Once again say that what is the condition for rational numbers? A number, which number we are selecting, that number which can be expressed, that number should be expressed, that is suitable to convert that one in the form of P by Q, then we will call that number as a rational number. Still we have the two conditions. What are those? Here those P and Q, those two also should be integers. Why? Because integers means we have that negative values as well as positive values, and in the same way in the integers only we have that 0 also, no? So that's why here P and Q should be integer, and one more condition, Q not equals to 0. Maybe you may get that doubt here. Madam, you only saying that here P and Q are integers, but here another condition you given that one as Q not equal to 0. Why? Because here 0 is also an integer, no? Then why here Q is not equals to 0? Yes, that's why. Listen. So here P and Q are integers, I am saying 0 is an integer. But one thing, P by Q means that is in the form of P by Q. In division form, no, here P by Q. So here Q is in that denominator place. Q is in that denominator place. So if that Q is equal to 0, for example P is equal to, I am going to take here P is equals to some 2 and Q is equals to 0 I taken. So we have to represent this one as 2 by 0. Is it possible to divide any number by 0? Is it possible? 0 is divisible by any other number, we know that condition, but at least any one of the number also not divided by 0, which means 0 never divides any other number. Why? Because 0 into 1 is equals to 0, 0 into 2 is equals to 0, 0 into 3 is equals to 0. Then where you will get that 0 into something is equals to 2? Is it possible to get? It is not possible. No. Why? Because 0 into any number, if you take any number, 0 into any number, that is equals to, always you will get it as 0 only, no? That's why this is undefined. Okay, that is the reason for a number which is not divided by 0. Okay, 0 never divides any number. Okay, that's why any number is in the form of 1 by 0, 2 by 0, any number by 0 is there means that is not defined. It is not possible. That's why here the condition is Q should not be equals to 0. Q should not be equals to 0. Okay, that's why here Q not equals to 0 condition we have to take. Other than 0, you can take that any other integer, that is maybe any negative integer or positive integer. Okay, just let us see that integers I am saying no. So here I am going to consider it as a minus 3. Okay, minus 3, that is an integer. We can represent that minus 3 in a fraction form also. How it is possible? Do you know that? Yes, see here. Minus 3 is there. Only I taken here the integer is a minus 3. I am going to convert this one into that fraction form. How? Means by taking 1 in the denominator. By taking 1 in its denominator. Now observe that here this is in the form of P by Q or not? Minus 3 by 1. So here P is equals to minus 3 and Q is equals to 1. In the denominator if you have that 1, then again you will get the same value only, no? Minus 3 by 1. So 1 into minus 3 is equals to minus 3. So what you will get in its quotient? Again you will get it as minus 3 only. Okay. And in the same way minus 4 is there, minus 4 by 1. Again 1 into minus 4 is equals to minus 4. So again you will get its quotient as minus 4 only. Okay. Or if you may take that 1000. Okay, 1000 is there, that is a positive integer. So 1000 by 1, yes, that is possible. 1000 is a positive integer and here 1000 by 1 is there. So in the denominator 1 is there means again you will get the same result. Yes or no, same result in that quotient. Okay, that's why we can represent that any integer. Okay, here you can take that 0 in its numerator. Okay, I told you that 0 should not be taken in that denominator place, but we can take in that numerator place. Why? Because 0 is there, 0 by 1. 0 by 1. So 1 into 0 is equals to 0. So in that quotient again you will get that 0 only, no? 0 by 1. Any number by 1. Again you will get the same number itself, no? Okay, that's why we can represent that 0 by 1. But in its reverse 1 by 0 is not possible. Okay, again I am saying 1 by 0 is not possible, but it's a converse. Okay, it's inverse. That is 0 by 1 is possible. Okay. So in this way we can represent that rational numbers. But here my doubt is natural numbers are represented with that which letter? Yes, starting letter of that word, that is N. And what about that whole numbers? Whole numbers starting with the letter W. So that's why set of whole numbers represented by W. Integers. You know that here I or Z. Why? Because Z means that reason also you know that. Okay. Why? Because integers came from the word. What is that? Zenith letter, that is no. So that's why we can represent that one with Z also. So afterwards here rational numbers. Here rational numbers starting with which letter? R. Okay, but here we should not represent that rational numbers with R. Okay, why? Because here we are not seeing that the given fraction. Okay, we can express that given number in the form of a fraction, but here always we have to concentrate on that quotient. Okay, did you observe or not here? In this case I told you that minus 3 by 1. Here after division we are getting the quotient as minus 3. Quotient as minus 3. Okay, and here this is minus 4. See, here always we are seeing that quotient part only, no? Quotient part. Quotient. 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 Quotient is the result form of division. Okay, we learn about that one in that primary classes, right? So quotient is that word which expresses the result of that division form. Okay, so here this is represented with the starting letter, that is Q. So rational numbers are represented by the letter Q. Okay, is it clear? So in this way we can represent that any number in the form of P by Q, but that condition is very important, that is P and Q should be integers and Q not equals to 0. Okay, before I'm starting this concept I told you that fractions, and I told you that fractions related to rational numbers. Why? Because when you observe these all numbers, here you can observe that fraction forms only, no? P by Q is nothing but a fraction form. Okay, so in that fraction I told you that only positive fractions are there, but come to that rational numbers, here you can see that negative fractions also. Why? Because minus 4 by 1, minus 4 is an integer. We can express that minus 4 in the form of P by Q. To express that minus 4 in the form of P by Q, we have to take in here 1 in its denominator, right? Okay, now here this is a minus 4 by 1. So here we can observe that negative fractions also. So in that rational numbers we can observe that positive fractions and negative fractions also. Okay. So after that, here rational numbers we can represent in that two forms. Rational numbers we can observe in that two forms. How many forms we can observe? We can observe in two forms. So first one is the terminating decimal form. Terminating decimal. Terminating decimal form. Second one is recurring. So we can observe here rational numbers we can represent in, we can observe, okay, in two forms, that is in terminating decimal and recurring decimals. So what about the terminating decimal? So here terminating decimal means always we are observing quotient part, I told you, no. So here I am going to take that example as 1 by 2. What is that? Example as 1 by 2. So after this one, you know that decimal part, right? How to convert that fractions into decimals. So after cancellation, here you will get that 0.5. Yes or no? After that cancellation, you will get that 0.5. Once see that 1 divided by 2. Okay. So here 1 is less than 2. That's why keep here 0 and point, and here take that as 0. So 2 5 10. Okay, so in that quotient part, what is that value here? In that quotient part, we can observe that is 0.5. Okay, just observe here next one. Here 2 by 5. What is that? 2 by 5. 2 is divided by 5. Okay, again 2 is less than 5, no? So here take that point and here 0. So 5 4s 20. Okay, and its remainder is 0. Okay, that's why here we can observe that the quotient part is 0.4. Okay, I will take one more example, that is 1 by 3. 1 by 3. So here 1 is divided by 3. So again same process, 0 point. So here 0. 3 3 is 9. Again left over 1. Again 3 3 is 9. So 0 and 9. Again 1. So again 3, again 0, 9, so the remainder is 1. So in this way, when you observe this all cases, in that every step you can observe that 10, 9, 10, 9 like that. So that is in still continuation process, right? Is there any changes in that any step? There is no change in that. So in the decimal part we can observe that 0.3333 and so on. Why? Because here we don't know that where we will get that end point here. Okay, so that's why here this one we can observe that 0.333 and so on. Okay, here I am saying about that terminating decimal and non-terminating decimal. Once observe that these three examples also. So first one 1 by 2 is equals to 0.5, 0.4, 0.3333 and so on. Did you observe any change here? Okay, any difference in between those three fractions? Or in that three quotients, did you observe any difference or anything? Okay, just observe that here 0.5 after nothing is there. Okay, so 0.5 only, that is the value of 1 by 2. And here 0.4 only there, that is the value for the 2 by 5. But when you observe this one 0.333 and so on, here did you observe any end point? End points not there in this decimal form. Okay, but these two are having endpoints or not? Yes, of course, these two are having endpoint and a decimal part. Okay, that's why we will call these two fractions or these two decimals, we will call them as terminating decimals. So terminating means which has an end point, a decimal part which has an end point, then we will call those decimals as terminating decimals. Okay, and what about this one? Okay, 0.333 and so on. Here this is not having any end point. So we will call this type of decimals are known as non-terminating decimals. Non-terminating decimals. Okay, non-terminating, terminate means it has an end. Terminate, okay, to terminate means to remove that. Okay, so after that 5 we are not having any other places, so it should be terminated up to 5 only. 5 after terminated means here nothing is there. Okay, but here not like that. 0.333, that is in continuation form, there is no end point to that. Okay, that's why we will call that one as non-terminating decimals. Okay, so this one only recurring decimals. Non-terminating decimal, you observe that. Okay, what about that recurring decimals? Recurring means which one of that, any one or two places or three places, whatever it may be, in the decimal part, if you observe that the same number should be in repetition, the numbers are in repetition, then we will call those decimals are recurring decimals. Then we will call those decimals are recurring. Recurring means just a repetition of the digits in decimal part. Okay, repetition of the digits in that decimal part. Then we will call those decimals are recurring decimals. So 1/3 shall we call that one as a recurring decimal? Yes, that is an recurring decimal. Okay, is it clear? Did you observe that what is the difference between terminating decimals and non-terminating recurring decimals? Okay, that's why here we will call that rational numbers are in the form of non-terminating recurring decimals, non-terminating recurring decimals, and in the same way terminating decimals. Here maybe you may get that doubt, madam, here you are saying that terminating decimals are rational numbers, but why you are saying that non-terminating also rational numbers? Okay, why? Because here you may get that doubt, 0.333 and so on there. 0.5 conversion into that fraction form, how we can convert? Here which number is there? 5. And here point after how many digits we can observe? Only one digit, so we can write that 10 in its denominator place. Okay, so after cancellation we are getting again 1/2, so that is a fraction part or not? Okay, so we can convert that a decimal form into fraction form into decimal form. But what about this one, 1/3? Okay, 0.333 and so on. So here I am asking you that in the decimal part how many digits are there, we have to consider that one I am saying. But here 0.3333 and so on, the same digit is in repetition, but how many times it is in repetition? Do you know that? We don't know that how many times that is in repetition. That's why here you may have that another doubt. Here that one we cannot express in that again 1/3 form, right? I mean p/q form. Then how you are saying that is a rational number? Why? Because 1/3 after cancellation only we got that 0.333 and so on. Okay, it is possible to convert into that fraction form, but we have to follow that one of the method. Okay, I will tell you that one here. Okay, so this number how to convert into that p/q form. If you learn about this number, then you can easily convert that any other recurring decimals into that fraction form. Okay, so listen carefully. So let I am going to take x is equals to, okay, we don't know that is a which number, fraction form we don't know that. That's why that fraction form I taken as x. So x is equals to 0.333 and so on. Okay, so point after how many digits are in repetition? Okay, which digit is in repetition? 3 only, no? Which digit is in repetition? Only 3. So a single digit is in repetition. Here we have to observe that a single digit is in repetition form here. A single digit, point after only single digit is in repetition. Okay, that's why here this number should be multiplied with 10. Okay, why? Because that is multiplied with 10. Because the point after only one digit is in repetition. Okay, for example 0.252525 and so on, like this number is there. So here point after how many digits are in repetition? Yes, that is 25. 2 digit number is in repetition. Okay, here we can observe that a 2 digit number is in repetition. Next we can observe that 3 digit number is in repetition, 4 digit number is in repetition. Okay, so here 1 digit is in repetition, so I taken here 10x. But here 2 digits are in repetition, that's why we have to take that one as 100x. Okay, 3 digits are in repetition, 1000x. 4 digits are in repetition, 10,000x. Okay, like that. So here 10 into x, we have to multiply that given number into 10. So here you will get this one as 3.333 and so on. Okay, so this is equation number 1 and this is equation number 2. Now we have to subtract that 1 and 2 equations. When you observe these two equations, which one is greater? For that subtraction process, you know that always we can subtract that the smaller number from that greatest number. Okay, so here greatest equation, how we can say? Just compare that LHS part. Here only 1x is there, here 10x is there. Which one is greater? Yes, that is 10x only greater. So here subtract that 2 minus 1. Subtract 1 from that 2. So here 10x is equals to 3.333 and so on. And here 1x is equals to 0.333 and so on. So subtract these two here. Okay, what you will get? 3 minus 3, 0. 3 minus 3, 0. 3 minus 3, 0. So this is cancelled. Here also you will get that 3, 3, 3 and so on, you know. So here also 0, 0 and so on. Point 3 minus 0, that is 3. Okay. So which is equals to 10 minus 1, that is equals to 9x. Okay. So at last 9x is equals to 3.00 is there, means we can consider it as 3 only, no. So 9x is equals to 3. So here from this one, x is equals to 3 by 9. Yes or no? So here 3 ones, 3 threes. So x is equals to 1 by 3. Actually that one only no fraction form here. 1 by 3, to that 1 by 3 only we got that quotient as 0.333 and so on. So by using any method or something, here we got that, here we can express that given number in the form of p by q. Okay, that's why here recurring decimals also we can say that one as rational numbers. Okay, so in the rational numbers, not only terminating decimals, we can observe that recurring decimals also. Okay, non-terminating recurring decimals. Okay, non-terminating recurring decimals which has no ending, and in the same way the numbers which are in repetition. Okay, so those decimals we will call them as rational numbers. Okay, so after that in rational numbers I told you that 0.3 I am going to take 0.333 and so on. 1 by 3 value that is. So how to represent this one? Here we can write this one as 0 point. Which number is in repetition? Which number is in repetition means 3 is in repetition, no? So here 0.3. On that repetition number we have to keep that bar symbol. On that repetition number we have to keep that bar symbol. That bar symbol we will call them as, we will call that symbol as a vinculum also, no? Okay, so that is a bar or vinculum. We have to keep on that which number is in repetition, or 0.638, 638, 638 and so on. Like this, any one of the decimal is there. How we can express this? Yes, 0.638. 638, 638, 638. So 3 digit number is in repetition, no? So that's why on that 3 digits we have to keep that bar symbol. Okay. So here we have to discuss about that period and periodicity. What about that period and what about that periodicity? Okay. So here what about that period? The number, the decimal part which is in repetition. The decimal part which is in repetition, that part is called here period. That part is called period. Which number is in repetition? Okay, that is called period. In that repetition, how many digits are there? That one represented, that is known as periodicity. Okay, number of digits are in repetition, that is known as periodicity. Which number is in repetition? See the difference. Which number is in repetition? That is called period. How many digits are in repetition? That is called periodicity. Okay, just observe here. In 0.3 bar, what is called a period? Okay, period means under that bar symbol, which number is there? That is that period simply. So here 3 is there under that bar, so period is 3. And come to that periodicity, how many digits are in repetition? Only 1 digit. How many digits? 1 digit. Come to this number. Here period and periodicity. Okay, period and periodicity, how to observe this one? Here period, which number is in repetition? So 638, 638, on that bar, below that bar, which number is there? That is in repetition, I told you, no? So here how many digits are in repetition? That is called periodicity. So period means 638. Okay, 638 is that period, and periodicity is 3 digits. Okay, how many digits are in repetition? That is called periodicity. And one more example. 0.123456, 123456, 123456, and so on. Like this, one of the number is there. First we have to learn about that, how to apply that bar symbol. Okay, on that which numbers we have to apply that bar symbol, first we have to see. Okay, so here 0.123456. Once observe that 123456, 123456, 123456. Okay, so that number is in repetition, so we have to apply that bar up to 1 to 6. Okay, 1 2 3 4 5 6 is in repetition. Now here period. Okay, and periodicity. Okay, so period is equals to 1 2 3 4 5 6. Periodicity, how many digits? 6 digits. So here periodicity is 6. Okay, so like this way we can write that period and periodicity. We will have that some problems also in that worksheet. We will discuss there. Okay, so this is about that rational numbers. Once again I am saying that rational numbers means a number which can be expressed in the form of P by Q. In the form of P by Q, and here P and Q are integers. Q should not be equals to 0. Okay, and I told you the reason also. Okay, so after that we can observe that rational numbers in two forms. What are those? Terminating decimal form and non-terminating recurring decimals. Non-terminating recurring decimals. Why? Because non-terminating recurring decimals also we can convert into that P by Q form by following that one of the method what I told you previous. Okay. So after that here and the two main very important concept, that is period and periodicity. Okay, so you have to learn about that which one is period and which one is periodicity. You have to see the difference between those two. Okay, so this is about that rational numbers. In that next class we will discuss about that irrational numbers. Okay.